Hi, welcome to the Calculus 1 lecture series. And this is the video we're going to start with the chapter 4 practice test. So in this practice test, we're going to help you to review for our unit number 3, the application of the differentiations. Okay, let's go ahead and start our first video and let's take a look at how do we sketch the function. Okay, so let's go ahead and go to our practice tests here. Okay, so in here we talk about how to sketch the function. This functions here is f of x is x cubed minus 3x squared. As we talk about in the lecture, we have some general guidelines to help us in here, to help us to do the graphing here. Okay, so let's take a look. See here, let's follow the guideline and hope that after we went through this guideline, we'll be able to very easily to kind of graph our function. Okay, so first take a look at this f of x equal to x cubed minus 3x squared. So this is a polynomial. So what is the domains here? So the domains here will be all the real numbers, right? So it's R. Then the next things here, we say, well, maybe we can try to find the Y-intercept. So Y-intercept is what? Y-intercept is x equal to 0. When you put the x equal to 0 here, so what is Y-intercept? Is zeros, right? So this will be our point, 0, 0. So this is the first point. We'll be able to later to help us to graph. So let's try to highlight that. Then the X-intercept, okay? So let's take a look, how do we get the X-intercept? X-intercept is Y equal to 0. So that means Y equal to 0 is equal to x cubed minus 3x squared, right? Okay, now we can take the x squared. Okay, so we can take the x squared out, so we can see here, we can factor the x squared out. Let me try to write here. See here. Okay, let's try to write the other place here. Okay, so the x-intercept here is y equal to 0, right? So we'll say 0 is equal to x cubed minus 3x squared. So I can factor the x squared out. So this would be x minus 3. So that means what is here? So we will have x equal to 0 and x equal to 3, right? Okay, so the x-intercept, that means going to touch the x equal to 0. So here I will have a point will be 0, 0. And x equal to 3, I have 3 zeros here, right? Okay, so this is our other 2 points here. Okay, now this is the vertical asymptotes here. So the next is here, they say, hey, let's take a look at the asymptote. So for the asymptotes here, because we say the most for the asymptote is if you have a rational function and then the denominator equal to 0. So in here, this is a polynomial. So we don't have the vertical asymptote. So we'll say not exist. So we don't have the vertical asymptote. The same with the horizontal asymptote is when x approach to infinity. See here, because this is a polynomial here, we say we don't have the horizontal asymptote neither. Then the wholes here, this is not a rational function. We don't have a wholes neither. All right. Okay, now the next thing here is the critical points. Okay, so now let's take a look. How do we do the critical points here? Okay, so the critical points here, the critical point will be f prime x equal to 0, right? So let's take a look at what is my derivative of f prime x. F prime x, this will be 3x squared minus what? Minus 6x, right? So we said the critical points have 2 situations. First one is f prime x equal to 0. or the f prime x does not exist. But in here, this is another polynomial, so we don't have the point f prime x does not exist. So we set f prime x equal to 0. Then I can factor the 3x out. So this is x minus 2 equal to 0, right? So the f2 equal to 0. So then we'll say here, then what is the critical point? So it's x equal to 0, x equal, so this is equal to 0, this equal to 0. So I have x equal to 0 and x equal to what? X equal to 2, right? Okay, so in here, so let's try to write it out. So the critical point is x equal to 0, and so y equal to 0. And then when x equal to 2, so what is my y values here? So the f of 2 will be 8 minus 3 times 4, so it's 12, so it's a negative 4, right? So this will be 2 and a negative 4. Okay, so those are my two critical points. So I can plot this one also. So let's highlight that. Okay, so then the next things here, we want to take a look at the interval of increasing and decreasing here. Okay, so let's see here. So I have 0 and what? 0 and 2, right? So this is my f prime x, just like we did before. Okay, so if you put something is less than 0, let's take a look what happened to the f prime x. So if it's a negative, so this will be the negative negative. So what it will give you? Give you positives, right? And so here, this is the 0 and the 2. Okay, now the next ones here, if they have something between 0 and 1, so you have a positive and negative. So what it will give you is give you negative. Then if you have something greater than what you have, positive, right? So you get a positive. So after that, then I know my function is what? This will be increasing in here, decreasing in here, and increasing in here. So we're going to use this information when we try to graph it, right? Okay, so now let's try to write it. So where am I going to increasing? From the negative infinity to 0 and 2 to the positive infinity here. Okay, so where is going to be decreasing is from the 0 to what? 0 to 2, right? So it's pretty straightforward by using this graph. Okay, so now the next things here, they want to find the concavities here, right? Okay, so before we do concavity, let's just take a look in here. Because this is increasing, decreasing, so x equal to 0, what is this? This is a local max here, right? So I can say the local max is 0, 0. And then in here, let's take a look at the other ones here. This is decreasing, increasing. What is here? This is local means, right? Okay, so local mean, we have x equal to 2, then the f of x equal to negative 4. Okay, now let's take a look at the concavity. So that means I need to find the second derivative. The second derivative will be the 6x minus what? Minus 6. Let's factor the 6 out, so it's x minus 1 equal to 0. So if x minus 1 equal to 0, so what is my values here? So this will be equal to 0, x equal to 1. All right, so that means x equal to 1 going to be make the second derivative equal to 0. Okay, so now let's try to see the concavity. So this is 1, right? So this is 1. So this is the f double derivative now. So this is f of x here, right? So this is f of x. Let's see the positive and negatives, and so we can decide. Okay, so if for anything less than, so this is negative, right? For anything greater than 1, this is a positive, right? Okay, after that, then let's see what happened to my concavity. So this is a double derivative is negative. So I'm going to have a what? Concave down. And this is a positive. What I have here? Concave up here, right? Okay, so now let's try to write it, okay? So concave up, so where is this? 1 to infinities here, all right? And concave down is negative infinity to 1. Okay, so now I know what is this points here. This ones will be what? This will be the inflection point, correct? Okay, so this will be the inflection point. So I know the inflection point is x equal to 1. Let's take a look at f of the 1 is equal to what value is 1 minus 3 is negative 2, right? Okay, so I know the inflection point will be 1 and negative 2 here. So this will be another point we can graph here, right? So this is the local max, this is the inflection point, and where is the concave up and the concave down. Okay, so now let's try, okay, so when we try to graph it, right? So let's try to combine both these two graph together. So maybe it will help us to do that. So this is 0, this is 1, this is 2, right? Okay, so now let's try to see here. We said, okay, so 0, okay, so let's see here. We said from the first graph, it's going to increasing all the way to 0. So I know this is increasing, right? Then from the 0 to 2 is decreasing. So this is decreasing, even past 1 still decreasing. See here, then 2 is what is increasing, right? Okay, now for the, let's take a look for the concavities here is less than 1 is a concave down. So that means here has to be concave down and here has to be concave down. Then here has to be concave up because the 1 is the inflection point, right? So here is concave up here, okay? So now let's try to use all this information and let's try to graph it here. Okay, so now the graphing here, let's take a look. Let me try to get the good, okay? So first things here, let's see here, let's take a look. I have the intercept 0, 0, and the 3 zeros, all right? So 0, 0, and 3, 0. That means I'm going to pass in this point 3, 0, 1, 2, 3. I'm going to pass in this point, right? Okay, so this is 3, right? So be careful, this is 3. And then, okay, so any other things here we said, okay, so we have a critical point at the 0, 0, 2, negative 4, 2, negative 4, okay, 1, 2, and negative 4, 1, 2, 3, 4. So here, 2 and negative 4, right? So this is one of the critical point, and this is the local what? So this is the local mean, and this critical point is local max. All right, now the other ones here, we have the inflection point. So it's 1 and the negative 2. Okay, 1 and the negative 2 here. So 1 and the negative 2. Let me use a different color here. Okay, so the 1 and the negative 2, this is our what? This is our inflection point, right? 1 and the negative 2. That means the concavity going to change here. Okay, so now let's try to graph it. So based on this graph here, so we said I'm going to increasing concave down all the way to 0, right? Increasing concave down all the way to 0. So I know my curve going to go something like that. It's increasing, and it's a concave down. And now, after you pass 0, I'm still concave down, but I'm going to start decreasing all the way to 1, right? So that means I'm still, so I'm going down right now, but still it's a concave down. So my So my curve is bend like this, right? Then after one, see here, I'm continue going down, but now my concavity change. So I'm continue going down, but my concavity change. That means concavity is going to, that's the too exaggerate. All right. So my concavity changes here. That means I'm going to bend like this way, continue going down, 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 down. Now after they've matched the two, right? So what happens here? I'm going up and the concave up. So I still bend upward. So then my graph going to go like this, bend upward. All right. So that's what will be our graph here. So from this one, I know my, the guideline we talk about in our lectures here provide us enough information to do a pretty good graph. If you want to be a little bit more accurate, you can choose like a few points, like x equal to -1 to see what you have. So you can make it this leg is more accurate, but in general, this will be the form. So it's pretty good, right? All right. So now let's take a look at the second ones here, right? The second ones here, let's take a look at the f of x square minus x and minus natural log x. So the first things here, we talk about the domains here. So the first two terms, this is the polynomial, but the natural log x, I know what happened to the natural log x. Natural log x cannot be negatives, right? So my domain has to be running from where to where? 0 to infinity. Okay, so it has to be 0 infinity. So here, now the x-intercept is x equal to 0. What is the y? So I know the natural log 0 is not defined, so I cannot find the x-intercept, right? So I cannot find the y-intercept when the x is equal to 0. So y-intercept in this province here is not exist, right? So now the x-intercept here. So the x-intercept is y equal to 0, right? So that means 0 is equal to x squared minus x minus natural log x here. All right. So then here, if we solve this one, we said this one here is the natural log x is equal to the x squared minus x here, right? So we know the only point that exists here is x equal to what? X equal to 1 here. Okay, so this is what gives me the x-intercept here. So I will know the x-intercept. So this is my first point, 1, 0. Okay, let's highlight that. Okay, so now this one's here. Okay, now let's take a look at the vertical asymptote. Vertical asymptote is, we know the natural log functions, right? So we know the natural log function is something like this. Correct. So we know what happens here when they're getting closer and closer to 0, then this one going to closer and closer to the negative infinity. So when the x are close to 0, so you will know the vertical asymptote is when the x approach to 0. What happens here? So the f of x is going to approach to what? Approach to the negative infinities, right? So I know the y-axis is as the vertical asymptote. So what is the vertical asymptote here? Is x equal to 0, or you can say it's the y-axis. Okay, so the horizontal asymptotes here, the horizontal asymptote is when the x approach to infinity. When x approach to infinity, see here, so when x approach to infinity, so this term is a denominator, right? So it's x squared, and the x squared running way faster than x, way faster than natural log x. So I know the vertical horizontal asymptote does not exist. And since this is not a rational function, we don't have a what? We don't have a holes here. So we do have one asymptote, that's the x-axis. right? Okay, good. Okay, now let's take a look at the critical point. Okay, so the critical point is f prime x, right? So here x squared, so what is here is 2x minus 1 minus what? 1 over x, correct? Okay, so now let's see here. Then we say here, find the common denominator, so it's x. So this is 2x squared minus x minus 1. All right, and then let's try to factor it. So this is 2x, x, I think this is minus 1 plus 1, right? So it's 2x plus 1. So we said, so we said the critical value is the one either equal to 0 or not exist. So equal to 0, that means this one equal to 0 or this one equal to 0, right? So when this one equal to 0, I will have x equal to what? Negative 1/2. And x equal to what? X equal to 1. But I know take a look at my domains from 0 to infinity. So this cannot be, right? So the second thing we say it could be is when the denominator is not defined. So we know that x equal to 0, this is not defined, right? So this could be the critical point. But x equal to 0 is not in the domain neither. Right, so it's not in the domain. So what do we do here? So this is not. So what do we have? We only have one critical point, right? So it's 1, 0. Okay, so now I can write it. I will say my critical point here is 1 and 0. Okay, now let's take a look like we did before. Let's see. So I don't need this long. Okay, so then let's take a look. Where is increasing, decreasing, right? So this is 1. Okay, so this is f primes, right? Okay. So let's see the positive and negatives, right? Okay, so when x is something less than 1, between 0 and 1, so your denominator is positive, right? It's between 0 and 1. So in here, you will have what? You will have a negative. So overall, we'll give what is negative. Okay, now if something greater than 0, your denominator is positive. So this is a positive, positive. So what happens here? This will be the positive, right? Okay, so this will be the positive. So now we can try to graph it. So this is negative, so is what is decreasing, and it's positive is increasing, right? Okay, so this is going to give us pretty good information. So we'll say the increasing is from what? 1 to infinity. Where is it decreasing? Is from 0 to 1 because my domain is from 0, right? Okay, now that's good. Okay, now let's take a look at the second derivatives, right? So concavities here to see maybe concavity to see how is the concavity help us. All right, so the f double prime x is here. I'm just going to use this one to take the derivatives, right? So this will be 2 negative 1, the derivative is 0, minus x1, so it's a minus 1 over x squared, and here it's a plus, right? So the chain, like the negative. So this one, the 1 over x is x to the negative 1, so you use power rule, negative 1 times next is a positive. Okay, so this one's here, we have x squared, and this is a 2x squared plus 1. So if we set equal to 0, all right, so what did that mean? There's no such x, right? Because 2x squared plus 1 cannot be equal to 0, and x squared equal to 0 is x equal to 0. It's not on the, it's not on the domain. So then let's take a look. So our domains here is from 0 to the infinities, right? So for all the values here, so for all the values in these domains here, the the top will be positive, will be positive. So the whole thing is positive, right? Okay, so this is your F double prime. So this is F. So this is F. If it's a whole thing, it's positive. And then it's what did that mean? That means your function is concave what? Concave up. And I don't have inflection points here. All right, so now let's try to write it. In interval concave up is what? Is 0 to infinity here, right? And what is the concave down? No, okay, not exist. So this is decreasing, increasing, decreasing, increasing. So what do we have here? Decreasing, increasing, so we have local means, right? So I don't have a local max. So the local means here is 1 and what? 1 and 0. I don't have a local max here. And do I have an inflection point? No, I don't have an inflection point. Okay, so now let's take a look at let's try to go to the informations here. So we said what is here? Let's try to highlight the things we can graph here. So this is 1, 0, critical point is 1, 0. I do have I do have the vertical asymptotes here, right? So okay, so let's try to graph it. Okay, let's go down here. All right, so here 1, 0, right? So 1, 0, this is my critical point. All right, so remember we said let's try to combine these two graphs together. So this is 0, 1, right? Okay, so from the 0 to 1 is decreasing, increasing, right? And from this ones here is a concave up, always. All right, so now let's try to do that. Okay, so now, oops. Okay, so now let's see if we can graph it. Okay, so 1, 0 here, then we know the y-axis is the asymptote. So from the 0 to 1, what happened? Decreasing. Okay, it's a concave up. And this is asymptote, so I know my function going to go like some, that's very difficult to draw nice curves here, right? So here, this is like an asymptote here, right? So not bad, all right? So it's go like this is the asymptotes here. And then after this is going to increasing, but this is local mean. So this is going to go like this. Okay. So if you want, you can kind of the plug into some, let me get this one here, right? So here is, right? So it's, this one doesn't approach to this axis, it's continue going like this. All right, so this will be our functions here. Like I said, if you want to be a little bit more accurate, you can choose a point. Maybe you can choose x equal to 5 and then see what is the value, and you will be able to mark the close point. So your graph will be a little bit more accurate, but based on those guidelines, you already can see what is the shape of the graphs here. All right. Okay, that's it. That is the part 1 for the practice test. And I hope that from these 2 problems, you will have a pretty good ideas how to, how to graph the function by getting all the information about increasing, decreasing, concave up, concave down, inflection point, and the critical points. All right, that's it. Okay, and looking forward to talk to you our second part of the practice test. Okay, bye.